All right, folks, in this video, I'm going to show you how to conduct a hypothesis test on a single sample. So a single X-bar and a single sample standard deviation. This is also called a one sample t-test. You'll find it labeled as such commonly. So this is the question that we're going to work off of. And my test statistic is, if you recall, is going to be the X bar minus mu naught over S over square root of N. And I've already filled in my null hypothesis here. The null hypothesis is always going to be the same. Mu is equal to some mu naught, whatever is given the status quo, if you will, the normal situation. So if we take a look at our problem, it says that the past sales indicated there was $100 per transaction. So I can start filling out some of my data down here. My mu naught then is equal to $100. Okay. After training your sales force, so anytime you see a problem like this, you always know that they probably want to do a right tail test because they want to be increasing the number of average sales. Taken from a sample of 25 salesmen, so I can use my N is equal to 25. Now be very careful here. The problem does not state that the underlying distribution of the population is normally distributed. We should have at least 25 observations. We're going to go ahead and assume that the underlying distribution is normally distributed, so 25 is okay for a salesman. Indicate that an average sale of 130. So our X bar is 130, okay, with a standard deviation of $15, right? Did the training work? Test your hypothesis as an alpha equals 5% level. So my alpha is 0.05. This is a pretty typical alpha level, so you'll see this quite often. So what they want to know is, did my training work? Mu minus mu naught. And I'm actually going to replace these mu naughts because I know what my mu naught is now. So in other words, my previous mu was 100. Did my training, I don't put 130 here, I put 100. Did my training mean that our average sales increased from 100 to some other unknown value? It's not going to be 130, it's going to be something else. We're not concerned with that. All I want to know is did our training work? So now we're going to switch over to our calculator here for a second. My calculator in this case is Microsoft Excel. And I'm going to make myself a template so I can use this for multiple tests. Now I know this is a right tail test, but maybe I can switch this over and do a left tail test and a two tail test. We might make in subsequent videos on those tests, but right now I'm going to do a right tail test. So I'm going to put mu naught in here. I'm going to make an area for mu naught, X bar, S, and I also know I'm going to need my degrees of freedom, so I'm going to put a slot for there for the degrees of freedom. I know that degrees of freedom is N minus 1. Okay, so what else do I need? I need my test statistic. So my mu naught here, if I look back at my problem, it says that it is 100. So 100, my X bar, this is seen from the sample, 130. It looks like, I mean, that's a pretty good increase in the average sales. So I'm thinking that we might be successful in our training. Our S is 15. Our number of observations, remember, is 25. Degrees of freedom is always N minus 1. I could put this in here as an indicator. N minus 1, okay? So this is equal to this top one minus 1. Anytime I'm creating a template, I also like to highlight in yellow the stuff I need to input. Anything else is going to be created itself, right? This formula is going to make this. Now my test statistic, if I look back at the formula for my test statistic, remember, it is X bar minus mu naught, oops, divided by S over square root of N. I have all of these pieces. Let me go ahead and create my test statistic. This is equal, and I'm going to put parentheses, X bar minus mu naught. This is going to be a positive test statistic. I can already tell because this is bigger than this, divided by, now I'm very careful here because Excel is very stringent about the order of operations. I put parentheses around this denominator. S divided by SQRT, the square root of N. That's 5, right? So I can calculate it myself. But if I want to make a template, I'm just going to put this in there as a formula, right? So down here, I can actually do my right-tailed p value, okay? My right-tailed p-value, I'll go back over here to my drawing real quick, is going to be taken from a t-distribution. Okay, so here's my test stat. My test statistic, and is the area under the curve to the right of that test statistic. Now that should be a fairly small number. I want that to be less than whatever my alpha is, so I can reject the null hypothesis. Let's take a look and find out what it is. In order to find that number, I do equals 1 minus. Now, why do I do 1 minus? Because remember, Excel always takes the area under the curve from the left to whatever number you give it. So this 1 minus will take me on the other side of that curve. 1 minus t dot dist of my test statistic, which is 10. That's a very large test statistic, ladies and gentlemen, comma. My degrees of freedom is right here. And cumulative is always true. That is pretty much mathematically 0. That p-value is way smaller than whatever my alpha value is. So we can safely say that we reject the null hypothesis and that our training did work very well and our average sales have increased.